All right. So let's do EKS like, whoops, hold on, let me switch. Whole window. How do I do a whole screen? There we go. Okay, explain Windows EKS like I'm 5. So I was just reading through this. I was like, oh gosh, there's a lot here. So let's try to visualize it. So, let me make the little. My favorite is to, you know, I like EKS Windows like I'm 5. Okay. So, all right. So the thing is, can I see it? Did I make the bubble? I made the bubble. Good. Okay. So, the starting, you can use host networking. Okay, so let's put that one in. Let's look at that first, right? Okay. So, what does that mean? Okay, so host process pods. Host process pods. So let's go over to that first. People new here. Host process containers enabled and containerized when it comes on the Windows host. So in Kubernetes, y'all are probably used to seeing this. Y'all are probably used to seeing pods that do this. Get pods -a. Okay, so y'all are probably used to seeing pods that do something like this. Edit pod kube system. So let's go in here. You guys are, oh God, Jesus. Okay. Okay, so you see this security context privileged equals true, right? That for a long time, that was not something you could do in Windows. Now, there used to be the ability to do something in the Docker days. It was easier to sort of hack Windows to do some of these things because there used to be a thing called Rancher Wins. Docker days, from the Docker days, and Rancher Wins evolved in those days, and that allowed you to basically do anything you wanted on the host because it would sort of like run on the host, and then you could sort of tell it to do crazy things, and it would go do them. That eventually evolved into this concept of this new thing, which is called CSI proxy for Windows, which was a more sophisticated take on the idea that you could have a Windows. So you'd have something like this, right? You'd have a, let me get, where's my diagram thing? Oh, here it is. I have two browsers because I'm doing some things in Arc now, but I'm still doing other things in Chrome. So it used to be like this. You'd have a pod. So here's my Windows node, and you know, I've got containerd, and containerd is running a pod, and then I can have the pod reach out to a thing that's running as a host, send it a command, and then run the command on there. So this is the whole, you know, oh my God, why won't it? This is the whole CSI proxy model, right? Is that a way to do host process? Before you could do host process was to just have a pod go tell something on the host to run it. But now you can do host process pods, which host process pods are, you actually use Kubernetes to schedule a pod, but the pod itself basically is running on the host. Okay? So that's kind of the way that privileged containers work on Windows. So EKS clusters must contain one or more Linux or Fargate nodes. So this is an interesting thing that I just learned about. So as you know, Amazon is a cloud and they have all these different services. One of them is Fargate, right? So you've got Fargate over here, and it's a different service. And I suppose you can have an EKS cluster. You can go and you can create a pod on that EK. Here's you over here scheduling a pod. You tell that EKS cluster to run a pod, and it can go and run that pod in Fargate. Okay, and in doing so, that pod is essentially the same as like any other Linux pod. Okay, so I guess that means that pods on Fargate can have IPCs that are part of a VPC, right? So if I was to say Fargate VPC EKS, if I was to Google that. I suppose there's probably something in here. Pods that run on Fargate are supported on private subnets with them. So your cluster's VPC must have private subnets available. So I suppose, and so people go and they make a only supported on private subnets. Okay, so I suppose, I'm just guessing here, but I suppose there's a requirement somewhere that I don't know, I'd have to look this up, but I assume there's a requirement that when you make EKS clusters and you want to do these Fargate thing. Now, the thing here to remember is that you can't do a Windows pod on Fargate, right? So this, you can't do that. Can't do that. These are only, Fargate pods are only for Linux containers. Kubelet and kube-proxy event logs are redirected to the EKS Windows Event Log. Okay, so are redirected to the Windows Event Log. That's weird. So you don't, that's so like in a TKG cluster, you can see the logs. So for example, if I was to, let's get out of here. What am I doing in here? kubectx. What clusters do I have? kubectl. Okay, so if I say kubectl get nodes -o wide. Oh, come on. SSH cap v at, and I'm going to SSH into this Windows server here. Okay. Okay, so in like a TKG cluster, I can go to cat var log kubelet, right? So I can go in here, I could cat var log kubelet, and I could see all the error logs for my kubelet. I can see what's in here. Let's take a look and see. So these are in the Windows event logs. So kubelet.log. Okay, so in an EKS cluster, right? There we go. What? What's in here? I guess it's all in the kubelet error log. I don't know why. So that's kind of interesting. I'll take a screenshot of that. Okay. So the kubelet error, that log. Oh, come on, Arc browser. I love Arc browser so much. But sometimes I just get a little frustrated. Okay. So here we go. This one, we're going to circle. We're going to circle that. Okay, so that log would be in the Windows EVT log. How do I check the Windows EVT? Can I do that from the terminal? Let's see. So check Windows EVT log from terminal. How do I do that? Okay. Right click on they're saying, how do I do this remotely? This is such a Windows thing. Who would do this? Can I do it? So check from PowerShell. Get event log commandlet. Okay, so I can run that. Okay, let's try and see if I can do that. How do I know? List event log. Oh my, get event log -- help. Oh my God, how do I know what the event logs are? Oh man. I don't know how to list event logs in PowerShell. Okay, get it. List all names of event logs in PowerShell. So there's probably, oh my God, every time you look at anything, is it get win event? What's that? I didn't run that. Get win event. What's that do? Oh my god, this is... What if I say list? Oh my god, it's so hard. How to find the name of an event log. This is the problem, right? Like when you have these things like these get API, get event log commandlet. Oh, Jesus. Use the event log commandlet PowerShell to pinpoint problems among them. Okay, let's see if this looks like a well-written post. System log. Common event log types and categories. Name of the event log to which events. It helps network. Yeah, like everybody's telling me what the event, but nobody's saying what. Oh, okay. This looks like somebody's actually trying to get serious here. Get win event. Oh, get win event dash list log. Here it is. That deserves a bubble, right? Get win event dash list log. All right. Let's try it out. Let's see what happens if we do that. Get win event dash list log. There we go. And if you do star, it gives you all the events. So in an EKS cluster, I don't have one up right now, but in an EKS cluster, you would use that. And this is kind of like hidden in this stupid terminal color, but I did list log here. So in an EKS cluster, you'd do something like that, and then you'd look in those logs. And maybe they have an EKS specific one. I don't know. I'm going to bookmark that. I love Arc Browser. Here we go. So, yeah. So keep that in mind. Okay. That's how you do it. That's it. Right? Okay. So, that's the secret thing. All right. Security groups for pods. So security groups, I suppose, don't work on Windows. There's like a new thing, these pod security admission. I don't know what the status of that is on Windows. But I don't think this is specific to EKS. I think in general, this idea that you can use these types of things in a Windows environment, like we don't test them on TKG either. It doesn't say why. Why does it say why? Windows security group. Kubernetes. And then everything that comes up. Oh, we have a doc on it. So that's good. I didn't know we had this doc. I don't know who wrote this. This is great. We probably need to add something to this. Pod level security. Linux specific security context mixes are not supported on Windows nodes. Privileged containers are not supported on Windows nodes. Instead, host process. Okay, so we need to add notes about security context, right? So whenever you see this, need notes about security contexts and pod admission. I think this page is a little out of date. was reading the EKS docs and realized I don't actually know what the standards for Windows pod security are. We probably should add whether or not pod admission works for Windows pods. Whether or not security contexts will ever work for Windows pods security groups. Wait, but didn't those get... They don't work anymore. Why? Never were implemented for Windows pods. But we got rid of them, right? Security context, Kubernetes. That was deprecated, so we should really be talking about that, right? Pod security, or security policy was deprecated, right? There's context. Oh, they're not the same. It's so easy to forget, isn't it? Don't forget this. One more important thing to know about pod security policy. It's not the same as pod security context. Okay. So security context is run, what user you run as, whether you, yeah, that's okay. And there's some secure. I thought we could have a Windows run user name. I could have sworn we could do that. But I guess, well, some of this stuff is Linux specific, like seccomp profiles or SE Linux options. But, you know, do we do run as user for Windows? I don't know. Let's see. Windows pod. I thought we did. I could have sworn we did. Yeah, we do. We do. Yeah, we do. So Windows options. So actually, pod security context, you do actually have Windows options. Look at that. I knew it. I knew it. Okay, so you do have Windows options. See? So you have Windows options. So you can do some of the security context stuff for Windows, but it's special. Special. Okay. Okay, so the Windows pods, you can do a security context on them, and some things like run as username exist, but obviously SE Linux and other ones don't exist, right? All right. We can close that. And we can close this. And we can close that. And we can close that. How do I get rid of this? So then there's security groups. And then security groups are a whole different thing, right? So then let's get rid of this. Oh my God. Every time I hit back, it just... What are you doing, Arc? Okay. Cool. Security group. So now let's go in security groups for... No, I'm not trying to go to the Amazon docs. Do we have any docs about it in upstream Kubernetes itself? No. Well, yeah, I mean, I guess it makes sense that we wouldn't have docs for AWS security groups, right? That makes sense. Obviously, no docs for security groups in K8s.io. It's not an upstream thing. Okay. So, so there's security context. Okay, so there's security context. Let me get my terms straight here. Okay, so there's security context, which is here. I love you, Arc browser. There's security context, and we do support some notion of some Windows things for security context. Then there's security policy, pod security policy. And then pod security policy is not the same as security context. And pod security policy is being, I think it's, yeah, admission. So then they I think reference the KEP, because then what we went to is we went to pod security admission. And today you're not limited only to deploying PSP on your own custom admission controller. In the years since pod security policy was first introduced, we realized PSP had some serious usability. But they don't, where is it? I remember at one point people wanted pod security policies for anything. If you were a third-party vendor, you'd have to ship with it. Way to do that at Black Duck. So I guess at this point, the official recommendation was pod admission, pod security admission. At some point we moved to this. I don't know why we didn't link to it. Maybe you should update that blog to say that. But so the thing now is that we do this, right? So now what happens is, you know, you're over here and you create something, and there's a thing here that is essentially an admission controller that when you put your pod in, it decides what to do with that, right? So you can either enforce, audit, or warn. And like if you enforce it, literally, if you tell, say, I want to run a host network pod, and it's the pod security admission says, I don't support that on the cluster, then it immediately gets booted. Okay. I don't see why this wouldn't work for Windows pods. I mean, don't we have the ability to say, like, I don't want people running things as a particular username? I don't know. Like, I don't know. I just don't know. Pod security admission Windows. I mean, if I was to Google it, pod security admission Windows, I would think it would work. But I don't know. Maybe we don't. Maybe we didn't implement it. Nobody. It's nowhere. I'd have to watch this video about it. What is this? This guy made a video about it. Who's this guy? He's got a good mic, whoever he is. Windows. I'll ask. What about Windows pods? Okay. I don't know. Nobody's written about it. We're going to have to ask. We're going to have to ask, okay? I don't even know. I don't know whether Windows supports PSA. I'm just going to like admit my ignorance here. It's okay. You don't have to know everything. Okay. Let's go back. Let's go back. Where were we? So, again, recap. Security groups. That's an AWS thing. Security context. It's like an old thing. Security admission. Security context is still valid. Okay. And that sort of still works for certain things. And security context is not the same thing as the pod security policy. Pod security policy is a different thing. So maybe I should just visualize that here. You've got this, and then you've got PSP, and those are different things. PSP's over here. This is over here, right? Security context, right? This works. PSP's does not work. No PSP, but you can do security context, right? So just, you got to know that. All right. Custom networking. What is custom networking? Come on. What is custom networking? Let's find out. By default, when the Amazon VPC CNI plugin, so if I have a node, custom networking, what is custom networking on EKS, right? Hey, let's see is anybody watching? Zero. Nobody's watching me right now. All right. By default, when the Amazon VPC CNI plugin for Kubernetes creates secondary ENIs for so what does that mean? So, well, what that means is I've got a node here, okay? So I have a node that's sitting here. I have an EKS node. Here's my EKS node. And the EKS node has a pod running on it. And it has like an ETH0 or whatever the equivalent of ETH0 is on AWS. This goes and connects to my hyperscaler, hypervisor, whatever, right? But that pod has another device. It has, and this is an ENI, I think, and this is another ENI, okay? So I've got an ENI here, and I've got an ENI, separate NIC for the pod, right? And so this is like a secondary, and this is the primary. Okay. So, yeah. Got it? Okay. Can't use IPv6 with Windows nodes. I don't know why that is. Probably because it requires features in the EKS CNI controller. Right? I don't know. I mean, hey, let's get Luther up in here. Maybe he'll come hang out. Let me see. Actually, it's too late. I'm just too lazy. No EPVS. I don't know. No IPv6. Okay. But let's go back to this custom networking thing. So what would people do when it creates them the same subnet as a private net? There's a limited number of IPv4 prerequisites. Familiar with the Amazon VPC plugin for Kubernetes creates secondary networking. Version 2.3, blah, blah, blah. kubectl command on your... We recommend that you complete the steps in the bash shell. What kind of customizations do I do? Okay, setting up a VPC, configuring K8's resources. So here's an ENI config. Oh, so you can actually make special ENIs. You can customize the type of ENI in your K8's clusters on EKS. Okay, so you can go and you can customize that. I guess you can't do that for Windows. You get a canned ENI. I don't know what people do with ENIs, why they want to customize it, but okay. I don't know. I think that's it. So, okay. So it's this. So I suppose what they're talking about is that customizing this you cannot do for a Windows node. Okay? You're still going to get a new ENI for every pod. It's the same Windows. Now, one thing to know here is that these then require an annotation that EKS controller has to manage. There's some special annotation that happens to happen. So you also, something you should know about EKS is you also need a webhook thingy so that when a new pod comes in, you try to create a pod, it modifies it to have this EKS CNI webhook for Windows, and then EKS CNI makes the pod. Okay. Without that webhook, your cluster won't come up. Windows containers aren't supported for EKS pods. I already said that. I think I said that. But yeah, that Fargate thing, you can't do it. That's just a Linux specific thing. Can't retrieve logs. I don't think this has anything to do with Windows. There's a cooldown for IPVS's. This prevents traffic from flowing to an older pod with the same IPv4 address due to stale kube-proxy rules. So I thought there. So this is because the Windows terminating endpoints was never implemented. I think I was going to implement that, or I thought about implementing it or trying to, but I didn't have time. So you have this concept of Windows terminating endpoints. Who's Andrews? Like him worked on that. I don't know. Then he mentioned to me he was doing Windows, and then he implement some of it, or that the Windows wasn't implemented. We do the Linux later. But I think terminating endpoints would prevent a load balancer from sending things to another pod, even if the pod was still up. So I would think that terminating endpoints would solve this, but I think I should just leave that. Wouldn't terminating endpoints prevent stale forwarding? I guess because not implemented in kube-proxy. Right? So this could be done, but this bug has not been fixed yet. Or the implementation of terminating endpoints, which tells the kube-proxy, even though its endpoint is around, don't send traffic to it. That is not implemented yet in Windows. It could be at some point. The source controller is managed on GitHub. I don't know what that is. When specifying a custom AMI, so for Windows node groups, you have to add these roles. So if you make a special AMI, I suppose there's some connection. I suppose, let's make a sticky. What color should this sticky be? What is the connection between AMIs and AWS IAM Auth? Like, why would those two things be connected? That doesn't make sense to me. AMIs is a machine image. IAM Auth, something. Can I just Google this? Is this whole AI revolution? If your AMI application requires internet access to the user, it must be achieved through AWS identity role instantiated through CloudFormation instance, which creates an instance and assigns the profile. What is QUI? What is this? Is this some new Google thing? I don't know what that is. What is QUI? Okay. IAM and AMI. IAM. Use AWS IAM to control access to your restrict, review, disable password login. I don't see why you would, when specifying a custom AMI idea, add to your AWS IAM configuration map. Okay, so I guess we have to read what they said we should read. When specifying a custom AMI for Windows managed node groups, add EKS to your AWS IAM Authenticator configuration map. This is required for DNS to function properly. Okay, so you open this. What is this? This is so weird. The following. I don't know. Let's put this, what I always do is I just paste it in Miro and then I start putting all the information and then eventually something connects. Somehow I make the connection eventually. What is this? Let's just update our little bubble. I'm going to update the bubble. What is the connection between AMIs and IAMs? Okay, let's see. The following are limits and conditions involved with specifying an AMI ID with managed node groups. So I have a managed node group. So I have my EKS cluster and I have some Linux nodes in it and I have some Windows nodes and this is like a custom node group. Okay. And that custom node group now, let's say I want a custom AMI on it. I want to use a special Windows node made by my Windows administrator. You must create a new node group to switch between specifying an AMI ID and not specifying an AMI ID. So okay, so now I have to make a new node group. That makes sense. You aren't notified in, well, hold on. To switch between specifying an AMI ID in a launch template. So there's like so there's a launch template where you specify an AMI ID, and then you have one where you don't. Okay. I don't know. I think this is just basically saying you need a new node group. I mean, that just doesn't, yeah. You need a new node group for every AMI type. I think that's what they're saying. The cardinality between AMI type and node group is 1. You can't have 2 different AMI types in a given node group. I don't know. You aren't notified in the console when a newer AMI version is available. Update your node to know you need to create a new version of your launch template. Okay, with an updated AMI ID. You then need to update the node group with the new launch template. So you have a node group. So I have a node group. This is a node group. This is a node group. I'm allowed to mutate this. And once I mutate that, it'll cause new machines to come up with the new type of node. Cannot be set. So I can't set the AMI type. I can't set a release version. I can't set a version. These are Amazon owns these ideas. If I make a custom node, I'm stuck. I can't use the Amazon metadata constructs to manage my own node. That makes sense. When specifying a custom ID, add the EKS kube-proxy-windows to your AWS IAM Authenticator configurator. This is required for DNS to function properly. Custom AMI ID. RO learn, is that talking about route learning associated with Windows nodes? Your configuration matches similar to AuthCM. Maybe there's a hint in there. Why? It just doesn't make sense to me. Why would I need special AMI? Why would I need special? It doesn't make sense that I would need any special permissions for this node. I mean, the node is coming up. I'm defining the node as an EKS group. Shouldn't the node come up and then Amazon knows that it's a Windows node? So let's see. And I don't think this links to anything. This is the exact same page. Oh, it's downloading something. What did you do? What did you download? Oh my God, BB edit. That's what I have for my default. Okay, so what do we got here? Let's see what we got in here. You know, you can paste YAML into my row. Okay, so map roles. Okay, so I'm adding this kube-proxy-windows to a config map. What is an ARN? What is an ARN? What are... Oh, God, stop it. No, I didn't mean to leave my row. Amazon resource name. Amazon resource names uniquely identify AWS resources. We require an ARN when you need to specify a resource unambiguous across all of AWS. So this is like just the general primary key for any AWS thing. Okay, so you basically say that there's this Windows instance role. So I make an instance role for Windows. And what is this? While we're Googling the whole internet, we might as well just look this up too, right? What is AWS RO? Role ARN. It's not role learn, it's role ARN. Okay, I got it. Okay, so yeah, so you have a role. The role has an identifier. AWS, you have this concept of roles. Different machines play different roles. And oh God, what is this? Jesus. Okay, so this is role. This should be camel case. Role ARN, right? So the role for Windows has an ARN. And then I suppose this is important. So you have a private DNS name for that Windows node, and that defines the username of the node, because the node is like a user in a sense, right? It needs to be able to make API calls to AWS to do things. So it's in this group, EKS kube-proxy-windows, and that allows it to query the API server to get endpoints and services, which kube-proxy needs to do. So it's going off and doing all that. In the process of doing all that, that role needs to be associated in this config map, and I need to, I guess at some point I need to make a role. So the following are limits and conditions involved in specifying an AMID. So there's a new node group, custom AMI-ID for Windows managed node groups. So I have a custom AMI-ID. So it must be the case then that default Windows AMIs automatically have EKS kube-proxy-windows role associated with them. Special AMIs made by users have their own instance role and thus need to be added to EKS's so that they are allowed by the AWS workload identity stuff to access the EKS API server. Windows nodes need to get API. So I'm confused about why so I guess this Windows instance role is the secret thing, and I think what we need to know is like what is an instance role, right? So we got to go here. Amazon EKS nodes are standard EC2 instances. Let's just find the word instance. If the Amazon EKS CNI policy you created yourself is attached to an Amazon EKS node IAM role, we recommend. Nope, no luck there. So it's weird because you Google this and this comes up. Can I see the cached results? See, they don't have the cached results anymore. They used to have cached and you could see it. Instead of creating and distributing your AWS credit, let's see this guy, 2021. I don't know if this is still the case. This is a great blog post. Who wrote this? I probably know this guy. Who is this? Or girl, maybe it's a girl, I don't know. Get that node instance role of the Windows node group from the outputs. Search for the node used for the Linux node and then copy the row learn of that role. Once the AWS I don't know what this is. This screenshot sucks. Final step, running Windows application on the node. Okay, then you go to blah, blah, blah. Get the node instance role of the Windows node group. So that's this. Let's go back to our picture here. I just can't understand this without a picture. So I have this Windows node group. So I get the node instance role of that Windows node group. You also need to get the node instance role of the Linux in the EC2. Search for that node. So you get the, okay, so you have to make these. So there must be some magic that allows the nodes to, the default nodes from AWS. So maybe the only thing I could think is this. AWS must be baking the DNS related node roles into the AMIs. Since we can't do that, we have to add them as a config map and let AWS control plane reconcile them. It must be the case that this AMI, I don't know, but I'm assuming this AMI needs a role. And that has to be done because they have a config map and they have something that reads the config map and then writes that to AWS. Writes whatever that role information is to AWS. And then the DNS and all the other things associated with the AMI work properly. AWS then knows that AMI exists and adds DNS related stuff to it. That's the best guess I can make. Okay, that's it. All right. Like and subscribe if you learned something here.